okay? Okay. So we on chapter 19, we talking about electrical force and electrical fields. This is a new adventure compared with the Physics 31A. Is in this particular subject, the electrical force, electrical field, you cannot feel it. You only can see the net result of it. Then you will say, oh, that's what happened. So there's a lot of information in the book. I will not go over, in which case our hydraulical overview and other things is like insulator and conductors. This part section you should look at yourself. What is insulator? Insulator means it doesn't conduct the electricity, and conductors means it will have the electron flow in the metal material. We want to highlight the most important part is some of this you learned already, which is highlight them. One of the important part is related to the property of the electrical charges. We define the electrical charges. That is, the electrical charges are two types of electrical charges. We arbitrarily chosen. One is called positive, and then later on, the other one is called negative. Later on, we define that the charges held by the electron is positive charges. And then at the same time, the positive charges is held by the proton. So we separate them. So the people studied this in the 1800s, basically from the 1706 to 1790. People are studying on this. And about what is positive charges, what's negative charges, and then what would they react to one another. And then the gentleman, in these cases, do a lot of study on this. The people do a lot of study is Coulomb. Coulomb find out what is positive charges, what is negative charges, and by rubbing some plastic over some kind of air, they will produce some charges. And then you find out that the charges are two types. One is positive charges, and then another one is negative charges. And then, very important, they creating a lot of charges. In these cases, the positive charges and positive charge together, the force among them repel each other. On negative charges and negative charges, again, you repel each other. Negative charges and negative charges repel each other. Now, they try other way, in which case is the positive charges and negative charges reaction. What happened to them? The positive charges and negative charges, they attract one another. And then the negative charges and positive charges, again, is a charge of different sign. They repel each other, attract each other. So this is the next, and the next question to ask ourselves. So what is the force between them? What is the force? And what is the force in here? Equal to. So the charges is very small, and the Coulomb is a gentleman study on this. Very dedicated, spent almost his whole life studying about these charges business. So he in these cases, he had to study something that he can base on. Around in 1800, he studied these charges, the force among the charges. So you had something to go by, go back. So this is, again, we like you to follow this kind of step. So when he invents something, he had to go back to certain relationship to see what's happening. So he goes back to gravitation law. In the gravitation law, he says, if this is a mass m1, this is a Newton's m2, and then the separation between these two is r. Then he says the Newtons and Cavendish saying the force among these two is, in which case is called attraction between these two, is F sub g. So in F sub g, the gravitational force F sub g equal to g times m1, m2 divided by r squared. He got this. This is gravitation law, and or it happened long time ago in 1666. And then about 150 years ago, 1790, done by Cavendish, make this G calculation complete. Actually, this should be called Cavendish law rather than Isaac Newton's law. But Isaac Newton had the concept of the product of the mass. Now, Coulomb, he says, what happened? Well, how should we do it? So, basically what he says, the action between the mass is almost similar like the action of charges. So he made this postulate or assumption, in which case he assumed there's a charge Q1, charge Q2. And he said if it's separated by R, then he said there's a F sub E, the force among these two will be equal to K. K is a constant, almost equivalent to G, but he had to find out later on. Then F sub E equal to K sub E times K1 Q2 divided by R squared. He assumed this. Then the next thing he said to do is this gentleman, Coulomb, has to prove it. This is conceptual. He had to go to lab. There's a lot of law is conceptual, but you cannot prove it. So that's not is not useful. So Coulomb go to the laboratory and try to do this experiment and calculation. And then, thank goodness, he did prove this. And then at the same time, he did prove that he find out how to do the calculation of K sub E. So from this on, he defined K sub E himself. K sub E is related with the material constant in there. And K sub E turned out to be is a constant, almost like the G in gravitation. K sub E is equal to 1 over 4 pi epsilon sub 0. Epsilon sub 0 is a permittivity of a free space. So epsilon 0 equal to 8.8542 times 10 to minus 12 Coulomb squared divided by Newton and m squared. So he did this and calculated this. Then after this, he had to do a lot of testing, just like in medical field. We find out what medicine will work, but he had to do the clinical trial. In physics, we had to do a lot of trials. Instead, we say the clinical trial is a experiment trial. Do one step, another step, and finally they get the things done. So from this, we